Stage rep is go for flight.
FTS go. Prop go. GC go. Ground go. VC go. GC go. RC go. DC go. MD go. LD go. LD go for initiate triple count.
3, 2,
Liftoff of the Falcon 9 and Crew Dragon countdown.
Здравствуйте, друзья! С вами снова Альфа Центавра, снова Михаил Иванов, и сегодня мы смотрим стрим запуска Европы Клипер на Falcon Heavy. Что же, сегодня Falcon Heavy полетит примерно через 15 минут. Все блоки первой ступени будут израсходованы, ни один из них не вернется, потому что все топливо надо потратить на Дельта V, на то, чтобы отправить Европу Клипер в большое путешествие. Надо дать им максимальную скорость, поэтому такие жертвы. Сегодня мы в более расслабленном режиме все посмотрим, чем вчера, потому что вчера Starship это было просто безумие какое-то. Сегодня уже отработанный полет Falcon Heavy, хоть и уникальный аппарат, но как-то эмоции в начале стрима, по крайней мере, поспокойнее. После выхода на орбиту поотвечаем на вопросы. Будет такой расслабленный стрим. Напишите, пожалуйста, в чате, все ли хорошо со звуком. Ага. Говорят, нет голосов ведущих. Сейчас попробую. Появился ли звук с оригинальной трансляции? О.
Now on internal power. There is strong evidence of our ocean, of an ocean beneath that icy crust that could hold over twice the volume of Earth's oceans. And then Europa orbits Jupiter every 3.5 Earth days, with the same side always facing the planet. That is super fast.
That is 3.5. Think about that for a second. 3.5 days to orbit Jupiter. That's so fast.
Yeah. All right, and let's take a look at the launch countdown again. We are now 9 minutes and counting until Europa Clipper launches. And no issues to speak of right now. The weather conditions are fantastic.
And so one of the things that, is really exciting about Europa is that it's a place in our own solar system that could be habitable. And so this, going to Europa to study it means a lot for the astrobiology community and, of course, for humanity at large.
Well, Jenny, here we go with the final moments of the launch countdown. Let's head over to Daryl and Mick.
All right, thank you very much, ladies. And here at Hangar AE, we are continuing to monitor the launch countdown. And so far, we're at T-minus 8 minutes and counting. We're listening to the launch teams. They are monitoring some temperature data coming from the second stage LOX line that goes to the engine there. They're gathering data, so we're going to keep an ear and an eye on that. So far, everything else looks to be tracking okay.
Yeah, everything's proceeding forward with propellant load, and we did hear that stage 1 RP1 is complete on the 3
PY
boosters.
RP1 load is complete.
So things are continuing to move forward there, and propellant loading will be finishing up here shortly as the team gets the vehicle ready.
The team at JPL in California also on console for their spacecraft just shifted their spacecraft to internal power.
Yeah, they started transitioning everything to internal power. We'll get full confirmation of that in about 2 minutes, but things are good to go. And things are looking good on the preparations for the spacecraft as we move forward.
Engine chill has started.
There we hear the call for booster engine chill started on the 27 Merlin engines, getting ready for a liftoff at 12:06 p.m. today.
T-minus 6 minutes and 45 seconds and counting for liftoff of SpaceX's Falcon Heavy rocket with NASA's Europa Clipper spacecraft. At the very top, it is a beautiful day here in Florida for launching a rocket.
NYRP1 load is complete.
As we wrap up loading the RP-1 in the first stage boosters, we've just seen all three go completely filled. Now we await for all three of the LOX tanks inside the first stage booster to get to their full point. You can tell they're most of the way there. As you look on your screen there, you see the cold, the icy cold rocket condensing that Florida air.
Yeah, the team's continuing to load second stage also with LOX, and we're getting very close. We can see on the telemetry here that the LOX load of the 3 boosters is getting near completion. The team is continuing to follow the procedures and look at the vehicle, make sure that we are good to go for a launch at 12:06. But things are progressing per the procedure, Daryl, and all is looking good for a great launch with this beautiful weather that we have at Launch Complex 39.
Так, ну, вроде все получилось
Coming
наладить.
up next, we are going to start configuring
Теперь хорошо слышно меня
the
и
strong
оригинальный
back.
стрим.
Back from the rocket. That happens in a little less than a minute.
We just heard from the SMD and NLM that the spacecraft is verified on internal power, and things are looking good.
Нужно
for the
было
Clipper
поналаживать,
spacecraft.
поменять видеопоток. О, отлично, всем все
We're
слышно.
also listening to the launch
Остается
team
примерно
as
5
they
минут до запуска.
discuss
Летим к
the data
Европе.
coming in that they're looking at for the
Вопросы,
rocket.
куда летим? Отлично, спасибо.
The
Спасибо
teams
за
continue
реакцию.
to follow the procedure, as I said, and work,
Итак, как я и
work
говорил,
the, loading of
все
propellant,
блоки
finishing
первой
up the
ступени будут
topping of
израсходованы,
the
вторая
boosters,
ступень никуда не
and the
возвращается,
second stage,
попытаются спасти
as we
только
mentioned
створки
earlier,
обтекателя.
the 3 boosters are expendable fully. They will not be coming back for landing today. So
factory check
spacecraft,
starting.
SpaceX is getting the team ready to launch this vehicle today.
And you just heard the call out that the
Спрашивают,
strong
Паша
back is
выйдет?
retracting.
Павел ведет стрим на украиноязычном канале. Кстати, сегодня мы собираем донаты отважным ребятам на Покровском направлении на FPV дроны с крыльями, которые им очень помогут в борьбе с агрессором. Есть QR-код в углу экрана,
So we're getting some
в правом
discussion on
нижнем,
the
и
nets
есть ссылка.
regarding the
Это
second stage.
ссылка в описании. Это монобанка.
NY
Если
load is complete.
вы можете безопасно
We just got
задонатить,
completion of
пожалуйста, помогите.
LOX load for the Y booster. We're looking for now the center core and the plus Y.
Сегодня моментальное окно запуска. Если вдруг что-то пойдет не так и старт отменят,
Final status check.
то тогда только завтра будет следующая попытка.
Yes, LD, this is NLM on countdown 1, NASA spacecraft, and the NASA team is go for launch pending resolution of the anomaly.
Copy. Go pending outbrief of the issue being discussed on the anomaly net.
Affirmative.
Okay, Tim, so they've mentioned that they're working an anomaly. Tell me a little bit about it.
Yeah, so as we mentioned, they're monitoring some temperatures on the second stage, and things are the teams continue to look at that as they continue filling second stage with liquid oxygen. They're continuing to look at that and monitor
Center
that
core, LOX load
as
is
far
complete.
as they can into the count. So things are continuing to progress forward with LOX load. Center core is just finished up, so all 3 boosters are filled with LOX and RP1. The second stage has RP1 on, and we're getting near completion of stage 2.
Полностью заправлены все блоки первой ступени и доливают компоненты топлива во вторую ступень скоро закончат.
Stage 2 launch load is complete.
That they are go for launch pending the resolution of this temperature issue. So the team has continued to work that, and the team will continue to progress forward in their procedure.
And so these discussions are happening very quickly as we are counting down now inside the final 2 minutes until liftoff.
Absolutely, and we just heard that stage 2 LOX load was complete, and the team is working that. And as you said, this is what they do in the last.
Есть какая-то проблема с температурой во второй ступени, и команды следят за показателями, надеются, что все будет в порядке.
Ground gas closeouts.
We are now 90 seconds until liftoff. Weather is 95% go. These boosters on the outside, they have flown before. The Psyche mission, a little more than a year ago. They are back on the pad along with a brand new center core booster and a spacecraft bound for the Jupiter Moon Europa.
Yeah, Daryl, I can confirm, listening to the
Heavy is in
teams, that
startup.
everybody is go for launch. They have resolved the
Ракета в
temperature issue they
предстартовом
were looking at on second stage.
положении, все
Everybody's
системы
given the
готовы
go,
к
for
старту.
that, and Falcon is in startup, so the flight computer has taken over, and we're getting ready for
SpaceX
the final
launch
go.
director is go for launch.
And there we hear Charlie Meyer say that SpaceX is
Директор
ready for
запуска
launch, and,
объявил,
Europa
что
Clipper getting ready to lift off.
сегодня
There's
готовы
a great
стартовать.
update as now it vents out the locks inside the line of the transporter erector. We are inside of 30 seconds.
30 seconds and counting. Minus 15 seconds and counting.
And here we go. 10, 9, 8, 7, 6, 5, 4, 3,
3,
2,
2, 1.
Ignition. And liftoff.
Старт.
Liftoff.
Пошла. Сегодня взлетаем.
Unveiling the mysteries of an enormous ocean lurking beneath the icy crust of
Ух, как резво пошла.
Europa.
Engine chamber pressures are nominal.
Не помню, чтобы Falcon Heavy настолько резко стартовала.
Rocket beginning to roll,
Скорость растет.
putting down 5.1 billion pounds of thrust. Coming up, they're going to back off those engines just a bit.
Двигатели в центральном блоке первой ступени чуть-чуть уменьшают свою тягу, чтобы экономить топливо, пока их разгоняют боковые,
Heavy is supersonic.
чтобы потом с большей эффективностью это топливо потратить.
They have reduced power in the center core to get through max Q, maximum dynamic pressure on
Ну и чтобы
launch vehicles. We have
Max Q
reduced that.
пройти
Side boosters
полегче.
at full throttle.
A beautiful shot there as our camera team
Max Q.
locking into the rocket on a
Прошли Max Q,
The
все
vehicle
ровненько
booster
идет,
back down on Earth.
отлично.
And there we heard the call for max Q. The vehicle is passing through maximum dynamic pressure. Next thing up in about 2 minutes will be booster engine cutoff, where we see the two side boosters.
Через пару минут
engines all
будет отключение
shut down,
двигателей
ready for
боковых
booster separation.
блоков
The
первой
vehicle is
ступени и
performing
их
very well.
отделение.
Looking at all the telemetry that we have, power and trajectory are
Невероятно
nominal.
красивое зрелище. Всегда.
We've been flying for just under
Сегодня
2 minutes
обязательно
so far.
насладимся этим.
Everything looking good. These side boosters, once they do their job, they will be expended. If you're familiar with the Falcon Heavy, you know that they bring the boosters back on certain launches, but not on this one, because all of the performance is needed to push Europa Clipper into its proper orbit.
Things continue to look good as the vehicle heads down its ascent phase here. All telemetry is looking very nominal for this flight this morning. Falcon Heavy is performing very well.
We're just about 30 seconds away from separating those side boosters. Their engines will
40
go
секунд
first.
до отделения боковых блоков первой ступени.
MVAC is chilling.
Starting to chill down that MVAC-D engine in the second stage.
And that's where we need to get
А
the
на второй
engine,
ступени
chilled
уже
in
начинается
proper
охлаждение
temperature before flowing,
двигателя
liquid
реагентным
oxygen and RP1
компонентом
into it.
топлива,
So, they're conditioning the engine to
чтобы
make sure things are
не
ready
было
for
его
when it's
закипания
ready to, start
при
up.
подаче, при
Stand by
старте
for booster
двигателя.
separation.
Booster engine cutoff. Side booster.
Отключение двигателей и отделение боковых блоков.
And there they go.
Отлично отделилось, и теперь
Those two
двигатели
boosters
9
previously flown on
Мерлинов
Sunday. This will be their sixth flight. We
на
thank them
оставшемся
for their
центральном блоке
service
начинают
and
работать на
did a great
полную
job getting
мощность.
Falcon Heavy and Europa Clipper on its way as the center core takes over and continues mission down its ascent. Things are looking really good in the telemetry. Power and trajectory look nominal, and chamber pressures on the 9 center core engines look really good.
In just a little more 20 seconds from now, we'll get the cutoff of the main engine on the center core booster that remains. 4 seconds after that, we will separate. Flying out over the Atlantic Ocean. There's a look from inside.
There we
Vigo.
see
Смотрим внутрь второй ступени. Сейчас отделение первой ступени очень быстро все отработало. Все топливо очень быстро потратили в первой ступени во всех 3 блоках, и теперь работает вторая. Видите, как разогрелось сопло. А обтекатель-то еще не отделили. И вот это случилось. Европа Клиппер, аппарат почти свободен. Летим.
The glow of the MVAC-D engine as it performs its first burn here. This is about a 3-minute and 47-second burn. Things are looking great. Matter of fact, this is one of the shortest first burns that has been done on a Falcon Heavy by SpaceX.
Первое зажигание двигателя второй ступени чуть меньше 4 минут продлится. Это довольно короткое зажигание. А потом будет еще одно, чтобы отправить Европу Клиппер уже на траекторию, которая покинет, благодаря которой она покинет Землю, ее гравитацию. И отправится в свое путешествие, там будет несколько гравитационных пролетов, и к 30 году аппарат должен прибыть к Юпитеру. Что интересно, что есть европейская миссия JUICE, которая была запущена в прошлом году, в апреле, к космодрому Куру на Ариан 5, и она прибудет на год позже.
The second stage and on planet Earth.
Center core FPS has saved.
There we've heard that the flight termination system on the center core has been saved as it heads back to splash down. Things are looking good. I can tell you, Darryl, we had a beautiful weather day for launch, and as we're looking at MVAC flying in space with Europa Clipper, it is such a gorgeous view with Earth behind it, and so we could not have had a better day for a mission launch today.
О, можно посмотреть на лед на второй ступени, который всегда похож на мышей. Пока все работает отлично, запуск откладывали и из-за погоды, и из-за того, что в одном из предыдущих пусков были проблемы со второй ступенью Falcon 9, которая, отличается у Falcon Heavy. Но все проблемы решили, к сожалению, подробностей общественности не рассказали.
From our safety perspective, we're about a minute away from second stage engine cutoff as we'll see the MVAC-D shut down and get ready for a long coast, getting Europa Clipper into that parking orbit and on its way for the next firing that we will have.
Спрашивают, будет ли что-то еще отсоединяться или в этой конфигурации до Юпитера. Еще будет отделение, естественно, аппарата от второй ступени после последнего зажигания двигателя, когда отработает. Потому что тащить тяжелую ступень к Юпитеру никакого смысла нет.
brought to you, of course, by ground stations across the track that are pulling in the high-resolution data from the cameras. Burn looking good, just a few seconds away from cutting off from that first burn. And there it goes. The first burn is
И все, уже выключение.
Yep, things look really well on the stage burn result, apogee, perigee, and everything.
Вот так быстро. Не припомню, что вот прям вот за 8 минут можно было вот так выйти на промежуточную орбиту на Falcon Heavy. Что-то невероятное.
It's a long coast, and we'll hit that second burn, roughly 3 minutes and 21 seconds long. This one was roughly 3 minutes and 9 seconds, and Mick, you saw the data from it, and it all looked pretty good. Then there you go.
Сообщают, что попали на нужную траекторию, все отлично. А второе зажигание будет длиться 3 минуты с лишним. Тоже не очень долго.
And then, of course, what we're really looking forward to, Europa Clipper separation.
It's going to be a beautiful moment. If the pictures are as clear as we've seen so far, we will see it in all of its glorious detail.
Ну что же, пора, наверное, поговорить о том, какие приборы установлены на Europa Clipper. Естественно, будут есть камеры высокого разрешения, так что без фотографий мы не останемся. Как и спутника Европы, так и самого Юпитера. Есть термокамера, то есть мы увидим, какие разницы температур есть на поверхности, сможем понять, какие биологические процессы происходят непосредственно подо льдом. Есть спектрометр, благодаря которому, измеряя отраженный свет в разных диапазонах, можно будет понять, где какие соединения на поверхности находятся. Органические, соли, минералы. Будет радар, называется Ризон, который будет просвечивать лед, заглядывать под него, определять его и толщину, и понять, какие там подо льдом находятся водные объекты. Даже, может быть, сможет определить, какой глубины океан и его соленость. Будет ультрафиолетовый спектрометр работать. Он будет исследовать шлейфы водяного пара, выбрасываемые из спутника. Благодаря этому можно будет понять, что там, какой ее состав. Будет еще и масс-спектрометр, который будет анализировать состав тонкой атмосферы Европы. Там можно будет уже детальнее понять, из каких ионов состоит то, что выбрасывается с спутника. Будет еще и анализатор пыли. Он, естественно, предназначен для анализа вот этих мелких частиц. Плазменный инструмент магнитного зондирования. Он сможет, измеряя плазму вокруг Европы, отличить, какое магнитное поле индуцировано Юпитером, а какое есть собственное у спутника. И магнитометр отдельный будет измерять магнитное поле Европы. Он сможет еще и понять также другим методом глубину, толщину и соленость подповерхностного океана.
And how exciting would it be, right, if we could verify that there are the makings of life as we know it on Europa. So let's dig into the science that is going to make this possible.
К сожалению, первые ступени сегодня, блоки первой ступени сегодня сажать не планировали. Все топливо потратили на то, чтобы придать скорость аппарату. И так он довольно долго будет лететь к Юпитеру из-за гравитационных маневров. Поэтому, к сожалению, сегодня без посадок.
Original primitive organisms on Earth from which we all evolved.
I just love Europa's surface. I think it's one of the most complex surfaces in our solar system. Typically, when you look at another planetary surface, it's covered with craters, just like our moon.
There are shockingly few impact craters. That means something is going on to erase the craters, just like happens here on Earth, and on Earth we call that geology. One of the key questions right now that we have about Europa is whether or not there's plume activity.
Plumes are one way that you can definitely get ocean material to the surface. We really need a spacecraft in the system that's watching Europa to see when those plumes are happening, if they're happening. Europa Clipper is orbiting Jupiter, and it's
Можно поговорить еще о том, какой траектории Europa Clipper будет летать мимо спутника Европы. Это будут пролетные траектории, к сожалению, то есть Europa Clipper выйдет на орбиту Юпитера, а на орбиту Европы не выйдет из-за того, что там очень сильная радиация. Поэтому он будет быстро пролетать мимо спутника и делать все необходимые замеры и фотографии. Обычный подход НАСА к исследованию новых космических тел — это сначала орбитальная миссия, потом посадка стационарного аппарата и уже только третья миссия с использованием роверов или одного ровера. Все для того, чтобы собрать необходимые данные и спроектировать аппарат для каждого следующего шага максимально эффективно. Потому что все сразу сделать, пока у нас недостаточно опыта в космических миссиях, аппарат будет тогда слишком универсальным, намного более дорогим. Собственно, после того, как Europa Clipper отработает свою миссию, это откроет дорогу и к другим ледяным спутникам Солнечной системы, Энцеладу, например, который у Сатурна. Ну и, конечно, позволит придумать посадочный аппарат для посадки на Европу.
The pictures that we are going to get back are going to be just fantastic.
The legacy of Europa Clipper will be just a treasure trove of knowledge about this world.
Just to find an environment that is similar to the one from which life arose on Earth would really be groundbreaking. It would be awesome.
We don't know if Earth is the only place that life got started, or if it's really common. And a really important way to get at that is to understand, is there life elsewhere?
Спрашивает, найдет ли аппарат рыбу, если она там есть. Вряд ли, но можно будет понять, насколько условия в подледном океане Европы подходят для той жизни, которую мы знаем.
That's right, Megan. What a spectacular sight indeed. And like you mentioned, we have a very special guest with us, JPL Director Lori Leshin. Lori, congratulations first off on what a beautiful launch and now an exciting mission ahead.
What a great day. We're so excited. Thanks to SpaceX for the fabulous ride.
Absolutely. And, Lori, what would you like to say to the teams who have put in so much hard work and dedication, to this mission?
More than 4,000 people across many different organizations have worked on Europa Clipper, and we're so proud of them and so grateful for their hard work, for their families who've supported them, and especially the 150 or so with us from JPL who rode out the hurricane here. Thank you.
Absolutely. And, can you tell us a little bit more about why planetary missions are important in general that we go and study?
Well, it's really about who we are. Even though it's a robot we're sending out into space, it's a very human endeavor to want to explore the unknown, and especially to want to understand where life came from, how we originated, whether there could be other life out there. It's really a fabulous quest, and we're so fortunate to be able to do that through NASA's science program.
Definitely. And, can you tell us a little bit more about the Europa Clipper vault plate and why teams decided to include one?
The vault plate is so wonderful. It builds on a great history. People know about the Voyager Golden Record, which carried messages from Earth into deep space. It's kind of following in that tradition, and to have a special poem written by Ada Limon, the U.S. Poet Laureate, we're over the moon, over Europa, about being able to carry her words with us and to carry 2.6 million names of Earthlings with us as we go explore Europa.
Absolutely, a lot of special mementos on there indeed. You know, now that launch has occurred, what are some of those key milestones that the teams are going to be looking out for on its way, you know, on Europa's way to Jupiter?
Right. So just today, we'll be looking about 1 hour out is when we separate from the upper stage of the rocket. 3 or 3.5 hours out is very important because that's when our solar arrays, those giant size of a basketball field or basketball court solar arrays, deploy. We need those because we need power. And then in just 4 months' time, we'll fly by Mars for our first gravity assist. So it's going to be excitement all the way along on our way to Jupiter.
Absolutely. Lori, thank you so much for joining us again here today. Back over to you, Megan.
Thank you to Lori and Tony. And now I want to bring back Raquel, who's live at NASA JPL in California. I know the team, like here, erupted into cheers when the rocket lifted off. But now, Raquel, they're back at work and looking forward to what's next, right?
That's right. There was lots of cheering over here, but now here is a live look from inside Mission Control. You can see the team is getting ready for Europa Clipper's next milestone. Now, we showed you them gearing up for this moment, and now they wait for acquisition of signal, but there's a lot happening in there that you can't see. That's why I caught up with Mission Manager Tracy Drain. So let's take a look at a behind-the-scenes breakdown.
And Tracy, tell us about the space here in Mission Control.
Here in Mission Control, you'll see a lot of folks who are paying attention to the configuration of the spacecraft before launch, but our main role is to catch the baby, that's Europa Clipper, so that we're ready to control it once it's well on its way.
And you'll be right up front here with
Пока
your headset
прошла
on, talking to everyone in the
половина
room. Can you
времени
tell us what
до
is going
следующего
on behind the
запуска
scenes?
двигателя на второй ступени, наверное, можно сказать, что Европа Клиппер в марте 2025 года пролетит мимо Марса, совершая гравитационный маневр, а в декабре 2026 года у Земли. И потом уже только полетит к Юпитеру. Так что мы обязательно посмотрим на фотографии Марса, на фотографии Земли со стороны аппарата. Скучно не будет.
Behind them is Telecom, who is responsible for all the hardware on board, the radio, making sure that that's working so the spacecraft can communicate to the ground. And there are some other roles, too, who are ensuring that the data from the spacecraft is coming to this room properly. The phase lead sits over here, and her job is to understand all the things that are supposed to happen before and during launch, so that if things start to go a little sideways, she'll be heavily involved in making sure we understand how to deal with them. Navigation are assessing and understanding the track that the spacecraft is on once it separates from the launch vehicle so that the antenna on the ground can point to it and track it.
And then this row behind you, they're making sure Europa Clipper is healthy, correct?
That's right. While systems here is ensuring that all of the different parts of the spacecraft work together, the folks back here are paying attention to individual pieces. Avionics and flight software are paying attention to the computer and the software that's running on board. Fault protection is ensuring that if something ran on board in response to a problem, we understand what that is. Power is ensuring things like the solar array and the battery are producing enough energy for the spacecraft. Thermal is making sure that everything stays within the right temperature ranges. Propulsion
Смотрю на чат, обсуждаем, какие могли бы организмы жить в подледном океане Европы. Но, с одной стороны, я не хочу говорить, что там не может быть жизни, но прям так надеяться, что мы найдем совсем похожую жизнь. Лучше я буду приятно удивлен, когда это случится, чем буду надеяться на это.
Then we can use them to troubleshoot what's going on. And there's one more thing I'd like to ask you about. There is a tradition here at JPL that involves some snacks. Could you tell us more about this?
That's right. These are the Lucky Peanuts. And as the story goes, back in the 60s, an engineer was handing out peanuts during a launch just to ease the tension in the room. That one went really well.
Кстати, хорошее предложение. Накиньте лайков, придет больше людей, будет больше вопросов, будет о чем пообщаться.
As you can see, Tracy is here now, and the entire Europa Clipper team are in high gear. This isn't the only room where the team is hard at work. Let's take a live look at an additional operation room. This is where an overflow of the team is working during and after launch. Megan, back to you.
Thank you so much for that video
в
and
которой
tour.
расспрашивают, пожертвовали ли всеми тремя блоками первой ступени. Да, пожертвовали. Все ради скорости аппарата, чтобы он как можно скорее прибыл к Юпитеру.
Humans can be pretty smart, and we do discover a lot of great things, but there is still so much that we don't know.
This is like one of the most exciting times to be working in space.
I feel very fortunate and privileged to be supporting this mission.
Europa Clipper is NASA's flagship mission to explore a moon of Jupiter called Europa. Here's our Europa Clipper spacecraft being built.
How do you build a spacecraft to go visit a world that exists inside of this extreme environment?
What we're looking for is what's underneath the surface.
My name is Valeria Salazar, and I help put together all the hundreds of different components that make up Europa Clipper.
My name is Andres Rivera.
My name is Jenny Kampmeyer.
My name is Sarah Elizabeth McCandless, and I am an interplanetary navigator.
I'm Deepak Srinivasan, and I work to make sure that we can communicate with the Europa Clipper spacecraft.
And making sure that Europa Clipper makes its way to Jupiter safely.
I work on Europa Clipper, helping science fiction become science reality.
We're going to Europa to determine whether we have favorable conditions for life.
Here on Earth, no matter what environment you're in, wherever there's water, we found life.
We're going to investigate all those ingredients that we think have led to life as a whole.
But to actually do that, a lot of engineering has to happen.
There's no one person that is responsible for getting this spacecraft built, for designing our science campaigns.
I'm helping enable solar system exploration, helping to enable exploration of the universe.
We're doing some really humanity-changing science.
It's a hard journey to get here. It felt like an impossible dream.
For me personally, being an immigrant, I never really imagined that I would have the opportunity to participate in something like this. Just seeing it up here and knowing that it's going to be up in space, it's pretty humbling.
Seeing it from its infancy to actual realized hardware, to get that on its journey to Europa, it's just going to be a wonderful feeling.
It's been very motivating to see that a part of me will go to Jupiter.
I'm contributing this tiny part of something that's going to help us understand better about our universe.
We're going to be exploring literally the frontiers of life.
Who knows what mission today is going to be that inspiration for the next generation.
That's such an honor to be a part of.
Jenny, I love how emotional you get every single time we see some of the members of your team. And what's incredible is, you know, we did meet a lot, but that's still a fraction of the people who work on this mission.
Absolutely. And it's
Да, согласен с тем, что нет видео с камер, и это как-то с камер на ракете, и это как-то неправильно. Но это больше трансляция НАСА, чем SpaceX, поэтому, к сожалению, вот так. Они рассказывают о том, что им кажется, может быть интересно зрителям. Но поскольку миссия Европа Клиппер только запускается, никаких данных еще нет, то можно только рассказывать о процессе его разработки. Но и в этом вопросе они как-то не углубляются в предмет. А что касается варп-двигателя, возможно он или невозможен, то, что Алькубьери его математически показал, что его возможность, там для его работы требуется такое специфическое дело, как отрицательная масса. Мы ничего подобного пока нигде не видели. Так что на данный момент он никак невозможен, чтобы люди его создали. Никак это невозможно.
Sure. We want to understand whether Europa has the so-called ingredients for life. Liquid water, the right chemical elements, and then the energy that could support life. So understanding Europa as a whole can tell us whether those ingredients are there.
And you know, Europa is an ocean world. What kind of ocean are we looking at here? Is it going to be one like Earth that has, you know, a variety of warmer, cooler waters, or are we looking at something entirely different?
Probably not too dissimilar from cold oceans at Earth, Arctic oceans, but here covered with a layer of ice. But the temperature will be similar to Arctic oceans, probably salty. We're not sure how salty. And the pressure at the bottom of Europa's ocean is probably similar to the pressure at the bottom of the deepest point in Earth's oceans. Earth has a lot more gravity, but Europa's ocean is a lot deeper.
That's very exciting. You know, now that Europa Clipper has launched, how does it feel for you, Bob?
Надеюсь, что Европа Клиппер проработает около 10 лет. Полет к Юпитеру займет 5,5, так что если он сможет проработать Юпитера 4,5 года, будет отлично.
And now we're on our way, and 6 years from now, we'll start getting great data from Europa.
That is so exciting. I know all of us here are very much looking forward to that. Bob, thank you so much for joining us. We'll send it back over to you, Megan.
And actually, Jenny, you and I were just talking. Bob is one of those people who has been working on this for 25 years.
25 years, right? And this is really kind of I know how much this moment
Почему такие миссии не берут на борт жизни Земли, вроде бактерий, что в ее распространении где только можно? Во-первых, не хотят нарушать естественные процессы. Во-вторых, там условия вряд ли подходят для тех форм жизни, что есть на Земле. Ну а в-третьих, всякие простейшие организмы, вроде одноклеточных, и так распространяются через... просто улетают вместе с атмосферой от Земли, иначе бы снаружи МКС их не обнаружили.
Akemi and her team need to keep the spacecraft as biologically clean as possible to help protect this environment as well as the other planets and moons Europa Clipper will encounter.
We're really helped by this awesome clean room here. It does a lot of the work for us. We also monitor everything that's being brought into the clean room. Everything is very tightly controlled. It's cleaned before it comes in, and we sample anything that is going to come close to the spacecraft. We're sampling in 3 different directions, and each different direction gets a different face of this wipe. We want to give ourselves the best chance to pick up any bacteria that might be on here. This is the lab where we process all of our flight support samples. So I need to take this wipe that we use to sample the spacecraft's surfaces and get it into this bottle. And then I'll add some soapy water to this. And then from there, we're going to shake off all of the bacteria into that soapy water. We are using sound to widely shake all of the last little bacteria off into our soapy water.
And then we've moved to the next step, heat shock. What we're trying to do here is kill off all of the weaker types of bacteria and leave just the hardy bacteria.
Next, we're going to filter this. The liquid will filter through, and the bacteria will stick on top of the filter. From there, we put that onto a plate of bacteria food. From there, we let it grow for 3 days. We count every 24 hours for 3 days. They are really diverse, actually. They come in different colors. They can be tall and ridgy or really circular and smooth. Some of them really spread out. We use that number to estimate the number of microbes living on the spacecraft. Think of Europa's ocean like a nature reserve. We don't want to contaminate it with anything from Earth.
Out of the thousands of samples that we've collected, only about a dozen have required us to ask the engineers to re-clean the hardware so that we could go in and resample it.
All right, let's go back to Daryl and Mick to get another status update on the rocket.
Yeah, and we've been following this launch ever since it lifted off at 12:06 in 00 seconds Eastern Daylight Time from right here at the Kennedy Space Center in Florida. We are tracking since then the progress of this coast phase, and we do not have telemetry data currently for it, but we are expecting to pick that back up at our next ground station. We're currently flying over top of close to, as you can see right there, the southern tip of Africa.
Yeah, Daryl, the telemetry and ascent is coast is picked up by the ground stations across the globe, and we'll be picking up data here shortly. And you know, one of the new things that we'll be doing with Falcon Heavy as we get ready to start up stage 2 for its second burn, we'll be using the NASA TDRS network, the tracking data and relay system, to be able to pick up that start of stage 2 once that comes about. So that's a first time we'll be using that for Falcon Heavy, and things are looking great. So we are hearing that we just got at AOS from our Cape Town ground station, and we were watching telemetry. It just came back on the screen, so things are looking really good.
Вторая ступень с Европа Клиппер пролетает над Африкой. Станция в Кейптауне установила с ними связь. Пока все идет по плану. Судя по всему, индикация миссии временная внизу нелинейная. И как мы были приблизительно в середине по времени до следующего включения двигателя второй ступени, так мы примерно там и остаемся. Ну ничего. Посидим, посмотрим. Спрашивают, где Павел Поцелуев. Павел Поцелуев на украиноязычном канале ведет стрим. Можете подключиться, послушать, задавать вопросы.
Yeah, so more than 2.6 million people signed their name onto Ada's poem and her message out to Europa and out to the stars. And not only that, these names are not they're not digitally encoded in a microchip. They're actually etched. This kind of micro etching, nano etching
on that
tiny
which is
little
like the
chip.
size of a dime.
Exactly, 2.6 million names actually physically etched onto this plate that was attached to the spacecraft.
Because I was incredulous
Показывают чип, на котором несколько миллионов имен записано, и который летит к Европе. Не знаю, никогда не хотел, чтобы мое имя было в каком-то таком чипе. Но это вроде бы как хорошая интерактивная возможность повышения интереса к миссии. Спрашивают, сколько весит аппарат? 6 тонн. Примерно столько же, сколько и европейский JUICE. А вот из-за разных ракет вот такое отставание на год к прибытию к Юпитеру, хотя JUICE улетел раньше, на 1,5 года.
What a beautiful way to embody this mission, really, in this vault.
It's really incredible.
That's cool.
Yeah.
Okay, so the Message in a Bottle campaign was just one of several ways you could be involved in this mission. Some of you took part in an art challenge, so let's take a look at some of those pictures now. That's nice.
Показывают детские рисунки, то, как дети представляют себе Европу и наблюдение с Европы Клиппер. Океан удался подледный.
Yes, and in kind of our wildest dreams, we hope we see things like that.
A narwhal, yeah. Oh, this is really nice too.
Cool. Yeah, look at that. So that's kind of showing our trip out to Europa, and I love that kind of side view of Europa, seeing the ice and the water underneath. That's amazing.
And if you're home watching and you're saying, wait, I want to submit my picture, my masterpiece of Europa Clipper, there's still time, so just take out your phone and scan the QR code now that you see on your screen. The art challenge is open until the end of the month. Or if you like to wear your love for Europa instead, let's take a look at some other photos now. These are Jupiter and Europa-inspired fashions, and this was part of NASA's Style Challenge #Runway to Jupiter. They look very happy to be wearing the mission logo.
That's awesome. Those look like, I think, knitted or crocheted sweaters. Oh, wow.
This is my Halloween costume.
I could see that.
I'm going to dress up as Jupiter, and you're going to be Europa and just run around me.
That's great. Every 3.5 days, I'll run around you.
Oh, and these nails are pretty too. It's always nice to see, ways that people can bring their excitement for this mission onto fashion or art or anything like that.
Exactly, and connecting kind of their own creativity with science. Speaking of which.
And those nails, I feel like, put us to shame. Jenny and I bonded. We did some co-host bonding, and we got our nails done as well. You see, they're meant to look like the ocean. So.
That's right, a little watery blue marbling.
Yeah. So I hope you also liked our runway to Jupiter submission for y'all to consider. And if you want to check out some more of those fashions, those Jupiter and Europa-inspired fashions, again, we have another QR code for you now.
Все немного расстраиваются тем, что так долго Европа Клиппер будет лететь к Юпитеру. На самом деле это не так долго. Просто мы привыкли, что 2030 год будет когда-то там, далеко в будущем. Это совсем недалеко. Буквально вот-вот. Не успейте оглянуться, как
friends and family event.
Будем
This
смотреть
time
на
in
фотографии с
JPL
Европа
Von
Клипер.
Karman Auditorium, where we saw lots of cheering during launch, and among those celebrating are the family of Al Kangahwala, the Deputy Mission Manager for Europa Clipper. Al is responsible for overseeing
Спасибо
how the spacecraft
Геннадию за
operates,
донат.
navigates, and stays on course during its mission to Europa, and he joins us now. Thank you so much for joining us. Al, can you tell us about your role and the next few weeks for Europa Clipper?
Hello, Raquel. Sure, happy to. Along with Tracy Drain, we take turns in early operations, shift by shift, as you were mentioning, ensuring the health and safety not just of the flight system, but of the mission operations engineering teams that are making this all happen. Looking ahead past today, we have many activities ahead. We're going to be performing characterizations, deployments, and checkouts of the subsystems and instruments. Some will be required prior to our first trajectory correction maneuver in about 3 weeks. We call that part Flight System Characterization Part 1. And then the vast majority of the remaining checkouts will be performed after that. That'll put us kind of near the end of the calendar year. After that, we'll be performing a flyby of Mars on March 1st, 2025.
Speaking of flybys, Europa Clipper will have flybys of Earth and Mars. So how does that help it reach its final destination, Jupiter?
So we use planetary flybys to perform what you would consider to be like gravity-fueled maneuvers. The slingshot effect you get by flying by a planet or a moon gives us essentially the ability to add energy to the spacecraft trajectory and to put the trajectory in a more optimal direction. So to get to Jupiter, we'll perform flybys of Mars next year and then one of the Earth in December of 2026 prior to arriving in Jupiter in 2030. Of course, once we're in the Jupiter system, we'll be performing many flybys of Galilean moons. And you can think of every flyby of Europa as not just a scientific opportunity, but an opportunity to tailor and craft the trajectory to set up the ground track for the next flyby.
Yeah, so tell us about that. Like once it reaches Jupiter, what will the paths look like?
So after orbit capture, we'll be proceeding with a series of Galilean moon flybys to reduce the size of the orbit, the capture orbit, to one that's more in resonance with Europa's orbit. So about 11 months after orbit capture in April of 2030, we'll perform our first Europa flyby in March of 2031. And by around Memorial Day weekend in that same year, we'll be in full swing performing flybys about every 3 weeks.
Well, Al, thank you so much for your time. Megan, back to you.
Now, Europa Clipper is carrying 9 science instruments on board, and they all came from all across the country, as you can see on the map on your screen.
Yeah, isn't it amazing? There are just all of these institutions around the country that contributed instruments to the payload.
Показывают карту, на которой наглядно видно, как много научных институтов участвовали в разработке инструментов для Европы Клипер. Там действительно приличный набор сложных инструментов. Где-то там за месяц, за 2 до запуска выяснилась проблема с транзисторами, что они не настолько устойчивы к радиации, как предполагалось, было задумано. Но вроде как-то эту проблему решили и запуск переносить не стали. Увидим, сколько Европа Клипер сможет проработать у Юпитера. Она, когда прибудет, будет совершать гравитационные маневры уже у спутников Юпитера. Будет пролет мимо Ганимеда. Благодаря этому она сможет изменять свое наклонение и пролетать на разной высоте над самой Европой, над целью миссии. Самое минимальное расстояние, на котором она будет пролетать, всего 25 километров. Невероятно.
What happens when you turn on that flashlight and take a look at them again?
Oh, whoa! This one is bright yellow, this one's bright green. Oh, and this one's like red.
Isn't that amazing?
So what's happening here?
Yeah, so spectroscopy is basically studying how light interacts with objects and how it may tell us a little bit more about what is going on inside of that object. So looking under visual light without the flashlight, it looks one way.
Right.
But when we put UV light on it, like Europa UVS will do, it can help us see what the rocks are made of.
Wow.
And so that's what both MISE and Europa UVS are going to be doing in the infrared and the ultraviolet parts of the light spectrum.
It's really amazing what you guys can do from just imaging. Like you're not landing, again, this is not a mission that's landing a spacecraft anywhere, but look what you can figure out just by pointing a camera.
Exactly. By pointing,
light.
Pointing a camera and using different wavelengths of light, we can understand what things are actually made of. And that's really incredible.
Wow. I'm really glad you showed this because,
Yeah.
again, it's nice to see the instruments as they are, models here, but like to see the science in front of us immediately. That was really cool. Thank
Yeah.
you for that.
Awesome.
So again, these are just some of the 9 instruments that Europa Clipper has on board. We're going to show you the other 5 after we head back out to Tony, actually. So Tony, the Europa Clipper mission was developed with Johns Hopkins Applied Physics Laboratory.
That's right, Megan. And joining us virtually is Bobby Brown, the head of Johns Hopkins APL Space Exploration Sector Head. Bobby, can you tell us a little bit about where you are and how you and the teams are feeling at this moment?
Yeah, well, good morning. I'm standing here in the mission
Спрашивают,
support
не
area
повредят ли
east,
аппарат,
which is
пролетая
one of 2 mission
в высоте
support
всего 25 километров, поскольку, да, у Европы нет своей плотной атмосферы, то никаких повреждений быть не должно. Наоборот, надеются, что пролетят через выбросы, через такие условно гейзеры, смогут собрать эти частицы, их проанализировать и понять состав подледного океана.
Europa Clipper is among the most special of special missions that we do in planetary science. The science itself is amazing. It's something that's been in work for 15 years. The spacecraft is huge. It's going to a destination that you could really just dream of. You know, think about the moon, but the moon, you know, our Earth's moon, but with twice the volume of water that we have on the Earth. And our spacecraft's going there to explore. It's a very large spacecraft, very heavy spacecraft, and of course soon our magnificent solar arrays are going to deploy. These solar arrays are 100 feet across. So this is the largest, most significant planetary science mission of all time.
That's right. And can you tell us a little bit more about APL's contributions to this mission?
Yeah, well, a mission this unique actually took the best of the folks at the Jet Propulsion Laboratory and at the Applied Physics Laboratory working and learning together. This mission took the best of all of us to get this done. Here at APL, we've been responsible for the propulsion module and the communications electronics and antenna that are part of that module. The propulsion module is about 10 feet tall. It's about 2/3 of the height of the overall spacecraft. And we've also built, I'd say 2 and parts of a third of the science instruments. So the cameras that we were just talking about, those 8 megapixel, both wide angle and near angle cameras that were, when they were designed, had the same resolution as, say, an iPhone 10. Those were designed right here at APL. They're going to be able to zoom in on Europa to a factor of 5 greater than what we've seen on past missions like Galileo. We also built the PIMS instrument, which is one of 2 instruments that's looking at the magnetic field and the plasma surrounding Europa. It's going to tell us a great deal. Together, they will tell us a great deal about the ocean beneath the icy surface. And then with JPL, we worked on the MISE instrument, which is that spectrometer that you were just talking about in the previous segment.
That is very exciting indeed. I know we're all very much looking forward to the data that we get back from those instruments. Bobby, thank you so much for joining us. Back over to you, Megan.
Really cool to hear from APL, and thank you, APL, for your contributions to this mission. As promised, we now have models of the remaining 5 instruments on Europa Clipper. So, Jenny, what do we have now?
Yeah, absolutely. So we're going to start over here again.
Okay.
So now these 2 instruments, that furthest one is MASSPEX.
Okay.
And then the next one is SUDA. And then both of these together are a dust detector and a mass spectrometer. So these instruments are going to be kind of directly tasting particles that are in the environment around the spacecraft.
Tasting?
Yeah, so kind of as we're flying past, particles will be hitting their sensors and we'll be able to tell what they're made of, how fast they're going, and doing that kind of chemical analysis.
Oh, okay.
The 3 over here that we have photos of, because they're really big, so we can't have
You couldn't
models.
fit them on the desk?
That's right, they wouldn't fit on the desk. The 3 of these together are going to be able to tell us about the interior structure of Europa. So we'll start on the end with REASON. REASON is our ice-penetrating radar.
Okay.
That's going to help us understand how thick the ice is, places where it may be thinner. And then PIMS and our magnetometer are are studying the plasma fields and the magnetic fields. So let's talk a little bit about the magnetic fields because this is a really interesting part of Europa. So let's do a little demo.
Okay.
So I want you to hold this.
All right.
We're going to pretend this is Jupiter.
Right.
And you can see there's kind of a magnet inside with some of these iron filings. So go ahead and give that a quick shake.
Oh.
Yeah, shake it up real good, real good. There you go. Awesome.
Okay.
So now it might be hard to see, but you can see that that iron is flowing around like the magnetic fields of Jupiter. So if you were to just take a rock and move around, you know, you wouldn't really see much, but try it with that.
A magnet.
Yeah, so that one's magnetic.
Whoa, it's attracting all the little metal shavings.
Exactly. So that's basically, we're kind of pretending that this is Europa in this situation. So the way we discovered that there was an ocean underneath the ice is because there was a little bit of a wobble in the magnetic fields. And we were able to infer from that that there must be some sort of conductive layer underneath the ice.
I see.
And so if Europa didn't have that conductive layer of ocean, we wouldn't see this kind of interaction with the magnetic fields.
Gotcha.
So our magnetometer instrument that we have on the payload is super, super important.
Awesome. Thank you so much, Jenny.
Yeah.
All right, so we've been following along with the Falcon Heavy second stage as it continues its journey out with Europa Clipper. So let's head back to NASA's Daryl Nail and Mick Waltman for the next operational milestone.
Yeah, that's right. We're getting ready to relight the second stage engine on the second stage of the rocket, carrying Europa Clipper, and it is just moments away, Mick. We're at T plus 47 minutes and 30 seconds. Getting ready to relight. This is a longer
Планируют в самое ближайшее время запустить двигатель второй ступени.
ITO or interplanetary transfer orbit, allowing Europa Clipper to be separated and get ready for its Earth assist maneuver. And there we just heard the call for MVAC ignition. The engine was chilled down prior to this, and ignition has happened, and second burn is continuing on.
So this is a 3-minute and 21-second burn of the second stage. If you're familiar with the amazing views that we have at this point, then you know that we've got the camera on the second stage. However, we are not expecting.
Судя по диаграмме, уже произошло зажигание двигателя, и вы видите, как пошла изменяться траектория.
Ground stations leading up into this point, but for the duration of this second burn, we are pulling data through the TDRS network. The TDRS network, a legacy satellite system in geo orbit that is going to help us out fill in the gap so we can at least pull down the important telemetry of what is going on.
Yeah, we're seeing the telemetry coming through, and things are looking good on the telemetry. And but as you stated, we can't process that video through there from that aspect, and things continue to go for this burn.
Yes, the TDRS system covering 90% of this burn too. TDRS, of course, standing for Tracking Data and Relay Satellite Network. 90% of the burn will be covered by TDRS, but it's a much lower data rate than it is from the ground station. It's roughly on the order of 20 kilobits per second. If you compare that to your home internet connection, it's the pipe is about 5,000 times smaller.
Yeah, we have to choose what data we send. So we want to send the vehicle telemetry so we can see what's happening from a stage 2 velocity and altitude, and bandwidth for video takes up a lot more. So we opt to get the launch vehicle data, and things continue to look good for this burn.
Anyone who has downloaded video onto their phone knows about bandwidth. You got to have a good connection. You got to have a cell phone that's on a wide connection in order to pull down video. So we will not have video for any part of this second burn. Also, the spacecraft is not getting any of the telemetry.
Потому как изменилась траектория, вы сами можете понять, что витков вокруг Земли уже больше не будет. Когда двигатель закончит работу, аппарат выйдет вместе со второй ступенью на траекторию вокруг Солнца. Так что Европа Клиппер вернется к Земле только в 2026 году. Через 2 года всего.
As stage 2 is performing its job to get Europa Clipper into its orbit.
MVAC engine cut off.
Вот и двигатель выключен.
And we just caught some video of the right there at the end.
О, наконец-то смогли передать видео со ступени.
We've got some results there.
Там был не самый широкий канал для передачи данных. Впереди только отделение аппарата от второй ступени, и после этого где-то через час он развернет свои солнечные панели, которые в длину составляют около 30 метров. Все дело в том, что у Юпитера намного меньше солнечного света, чем у Земли, поэтому нужны такие громадные солнечные панели.
All right, it's been now about 51 minutes, nearly 52 minutes until since launch. Our coverage is going to take you through separation and getting the first possible signal from the Europa Clipper spacecraft. Let's head back over to JPL, where NASA's Raquel is somewhere new to tell us about the Deep Space Network.
Yeah, Megan, this is a wider look at the Space Flight Operations Facility at JPL, where NASA operates the Deep Space Network. This powerful system is able to communicate with spacecraft traveling beyond the moon. And joining us today is Amy Smith, the Deputy Project Manager for the Deep Space Network. Thank you so much for joining us, Amy.
Thank you for having me.
So your team is waiting to hear from Europa Clipper. Can you tell us why the Deep Space Network is so important with establishing communication with spacecraft?
Yes, so the Deep Space Network is part of NASA's Space Communication and Navigation Program, and it is the critical link between scientists and mission controllers on the ground and more than 40 missions that are exploring our solar system and beyond today. So the Deep Space Network is made up of 14 very large antennas strategically located around the world. We have a complex here in Southern California, one outside of Madrid, Spain, and another one in Canberra, Australia. And those are about equidistant around the world, as you can see in this graphic, so that wherever your spacecraft is, when it needs to communicate to Earth,
Спрашивают, почему сейчас не используют такое же питание, как в Voyager. Они действительно работают уже несколько десятилетий. Для этого нужен плутоний, и с его наработкой и использованием проблемы НАСА последний раз, по-моему, смогло его получить для марсохода Perseverance, так что это не так легко. Voyager были аппаратами, которые отправлялись в путешествие благодаря уникальной конфигурации планет, когда было несколько гравитационных маневров у планет-гигантов. В них вложили все возможное. Сейчас, к сожалению, флагманские миссии НАСА не могут получить настолько серьезное финансирование. Очень много средств отбирает ракета СЛС, поэтому есть то, что есть.
Is the carrier frequency. We'll see that pop up and we'll lock onto that, and then we can start to decode the data that's on there. And once we are able to decode data, we'll start sending that directly to the mission operations team so that they can use the data to see what's going on the spacecraft and make decisions about what to do next. Eventually, they'll ask the Deep Space Network to turn on the uplink, so we will establish coherent two-way communication, which means we'll still be collecting data, but then we can send commands to the spacecraft, and we'll start collecting that critical navigation data that the team needs.
Okay, thank you so much for your time, Amy. Megan, back to you.
Thank you, Raquel and Amy. And once Europa Clipper is launched, you can follow along with its journey using NASA's Eyes on the Solar System, which you can check out by scanning this QR code. It's a 3D program that allows you to zip around our solar system to learn about planets, asteroids, comets, moons like Europa, and spacecraft like Europa Clipper. And remember, Europa Clipper is not a life detection mission. Again, instead, it is looking for the right conditions that could support life. Now, a check on the clock. We are now 55 minutes from launch. We have time for some more social questions. This one actually is not a question. It's a well wish. This is from Tiffany Basket on Facebook. I think she knows you because she's saying, "Hi, Jenny." From all of us in Ohio at the Buckeye Online School for Success, we want to thank you for keeping us updated and inspiring our students to dream big. Good luck today.
That's just so heartwarming and amazing to hear from them. And I know they're all watching, so
Спрашивают, что еще интересное будет на трансляции. Примерно через несколько минут будет отделение Европа Клиппер от второй ступени Falcon Heavy. Это будет самое интересное из того, что осталось. Так что осталось подождать совсем чуть-чуть.
Yeah, so again, we're not a life detection mission. We are not really looking for like a biosignature of something that says like, wow, we found life, right? But we are going to assess its habitability. And if we find that this is a place that is habitable, the hopeful next step is that we would send a landed mission, that we could go in the future and actually land on the surface, take samples and all those things.
All right, let's go back to Daryl and Mick right now.
Very much, and we continue to watch the progress of Europa Clipper on that second stage of the Falcon Heavy rocket, and we're looking good so far. The telemetry we're seeing looks like the coast, again, is going well. We expect the spacecraft and the second stage to start to go into a little bit of a roll, and that's intentional, Mick.
Yeah, for thermal protection, to make sure that Europa Clipper stays cool and gets going, and we get that thermal roll that's going on. But everything's looking good, and the initial data we got from Stage 2 performance looked really good and nominal for that second burn. So we're definitely looking forward to Europa Clipper separation here shortly, as we can see this camera view of Europa Clipper on the front of the SpaceX Stage 2 launch vehicle.
Yeah, that's a great shot of the spacecraft going out the forward end. Europa Clipper, the largest spacecraft that NASA has ever built and sent into space on a planetary mission.
There we see the camera view of the MVAC-D that did its job in the shutdown, and the picture of Europa Clipper on the front of the Stage 2. Things continue to look good as we see the altitude of Stage 2 continuing to increase during this coast, and the velocity is ramping down into a steady state. Things continue to look very good, getting ready for separation in roughly 5 minutes.
Now we are having that video signal appear and then disappear. We do know that with the spacecraft doing that thermal roll, that can cause signal fluctuations, right, Mick?
Yeah, absolutely. We're on ground station tracking, and as it slightly moves around, we lose the connection a little bit.
Сигнал, к сожалению, пропадает. Надеюсь, что получится увидеть момент отделения.
We really want to be locked in at T plus 1 hour and 2 minutes and 32 seconds. That's the current time that we have for the separation of the Europa Clipper spacecraft. And that is a big moment, and we want to be able to see that because, as we've seen in some past NASA missions, it really looks impressive to see that spacecraft going off into its destination.
Yeah, and this being the largest planetary spacecraft that we've built, it's just going to be very cool to see this separation and go. And we heard Jenny and some of the team talk about it, but it just blows me away, the 30-meter, fairing of the solar rays. Wish we could see that and all, but this mission is just so excited, got so many people behind it, and we are just looking forward after this successful launch today. We want to get to this major milestone of separation, and things continue to look good for that from that aspect. We've had a lot of people, Daryl, over the years work on this. I'm going to give a special shout out to one of my own, my Flight Analysis Division Chief, Mr. Mike Carney. He has been working on a Europa mission for at least 25 years in his career. He started out as a trajectory analyst for a Europa mission way back when at Lewis. And when he came to LSP, he's worked on Europa off and on over the years. So shout out to you, Mike, for the great job, and the rest of the team on Europa Clipper today.
We just passed the 1 hour mark of flight for Europa Clipper and Falcon Heavy. Second stage. As you can see from this trajectory, Mick, it's going away from Earth.
Yeah, this is that interplanetary transfer orbit that we talked about. That first burn got us into that park orbit around Earth. And this second stage, second burn on second stage did a great job of getting us on that way as we get ready to separate Europa Clipper to get ready for those flybys, to get those gravity assists to get out there to the Europa moon. Things look continuing to look very well on the stage performance as it coasts through, getting ready for separation. Trajectory looks nominal.
And Europa Clipper is going to be deployed in a very high radiation environment. If you watched our broadcast today, you learned a lot about the high radiation, extremely high radiation environment in its destination, but it's also in a high radiation area right now as this deployment is in the Van Allen radiation belts.
Yeah, we talked, one of the things that we had to monitor today during today's launch was solar proton flux. Team had to keep an eye on that for solar flares and things going on to make sure we heard earlier about the special radiation area where the electronics are and for the spacecraft. And so solar proton flux went very well today, and we got this launch off. Things looking really good. We're about a minute away from payload separation, expected payload separation. Things continue to look good as the stage 2 altitude continues to increase. Velocity has a steady state now for stage 2, and things looking really good for this portion of the mission.
Getting close now. Less than 30 seconds away from separation. There you see the Europa.
Остается 30 секунд до отделения аппарата.
Massive solar panels that you were talking about all stacked together. This is a big moment for the program, for NASA, APL, and JPL. Let's watch.
Аппарат не двигается, а у меня все время впечатление, что у него какие-то части начинают медленно двигаться. О! А вот теперь уже точно ясно, что он отделился. Никаких минимальных галлюцинаций больше. Все, Europa Clipper отправляется в свое большое путешествие мимо Марса, с возвращением к Земле, с пролетом мимо нее и дальше к Юпитеру и его ледяным спутникам.
The video, we can see that Clipper has successfully separated. Please say goodbye to Clipper on its way to Europa.
Now that voice you heard just there is the Europa Clipper flight director, Pranay Mishra. He's with the mission support team.
Okay, all stations, we are waiting for a sign of initial acquisition. Again, Telecom will confirm when we have carrier lock, and DDM will let us know when they see the first packet down.
Получили первый пакет данных от Europa Clipper, так что все отлично. Осталось развернуть солнечные панели, но это будет где-то через час. Ну что ж, друзья, сегодняшний запуск был полностью успешен, и на этом мы будем завершать нашу трансляцию.
This will be the first time the spacecraft gets information. Looking forward for that.
The hope is that they would get it in the next few seconds. We're now looking at a split screen. On your left, you see Europa Clipper. On your right, this is telemetry coming. Or actually, this is the ground station looking for a spike, looking for a handshake with the spacecraft. And we expect to see that in the form of a blip.
Daryl, as you say, they expect that here in a few seconds, but it can happen in a few seconds or anywhere from 15 minutes from now. So the team is closely monitoring this and looking for that, and we're hoping that we can gain AOS here very shortly.
Yes, there's a broad range of times for which AOS is expected.
Flight GNC. Oh. Just wanted to comment from the video that we could see that the sun was on the neg-Y side of the spacecraft. There were very low visible separation rates, and the negative Z-axis was pointed at Earth, so this should be favorable for comp.